Okay. John, if you wanna start this session with some brief discussion or what you wanted to include in here, because we're
Yeah.
going to the lab too for the Earth, if you needed to also in the previous sessions and also this session, you wanna have some summary or what you have in your thought, then we can go back to back on the items that we needed to identify.
Okay. Yeah, I'm still opening a few things up. And I did open up the chat too. So if you have any questions as we go through this, um, take a look at that. And also, maybe we can start off with talking. You talked about the Triad Starfest was this Saturday also. So we've been meeting Tuesday, Saturday, Sunday in the afternoon, mainly Tuesday and Saturdays, but we do have this Sunday afternoon catch up. But this Saturday is the TriStar up in it says Jamestown, but that's actually up by the Research Triangle, right? Is where that's located.
Yeah, it is in the
Greenboro.
Greensboro. Yeah, therefore, they have a special annual meeting and amateur astronomer and science. Me and John, we're gonna plan to attend there. Therefore, this Saturday, we don't wanna have any class specifically for the or sessions.
Yeah, I believe is this open to the public for this or
Yeah,
not?
it is. Yeah, it is free and open to the public.
Great. Which is
Yeah,
very nice.
yeah.
Okay, very
If you
good.
wanna, you can share that with the student in the high school and our friends that close by. And a few of my friends that from Raleigh and also Greensboro, they will be attending, and that's gonna be good collaboration.
Okay, very good. Yeah. So today we talk a lot about using Stellarium, and I do know with my computer, I get a little bit of an issue. I do two screens. My second screen, it throws it completely out of whack. Um, and I'm going to try to do my best. And a couple things worth noting when you use Stellarium is the web version is quite a bit different than the download version, and that they both have the same capabilities, I think, as far as a lot of what you can do. The program has a lot more capabilities, but they're trickier to use. The layout is different for each, and that's where it becomes a little special. And I don't mind. I'll go ahead. I've got the one open that is the program. And if I share that, can everybody see my screen okay? Is that coming up?
Yes.
Okay. So I've actually when you open
Is
this
it
up,
is it the app or it is the download version?
this is the program. This is the download version.
Okay.
And I'm going to have to move it back on my other screen because a couple things that are a little quirky about it. When you open this up in the download version, it will take up your entire screen. It'll want to do that. I do use a Mac. I think a PC is the same way. If you move to the top, you get options to minimize the screen, and that does give you option to get to other programs. Otherwise, it will just commandeer your entire screen, and you won't be able to do that. Also, I think I'm in my second screen. If I bring it down my first screen, I will lose you folks. But I don't know if you noticed this, but the orientation changed on this. It does, like you see, I'm moving things around. I like to go south first, is what I like to do, is always look south when I'm using it. And that allows me to kind of think of my orientation of the sky. That way, I think of how the sky moves is that everything is becoming up over here in the east and then coming and going over to the west. If you use the download version, what will happen is you notice I put the my cursor over here. Can you see all those tabs come up on the left side?
Yes.
Okay. The browser version is going to be a little different. It isn't quite like that. And also, if you go on the bottom, this will pop up also. And the buttons I like to use over here, you can change the rate. And so if I go back up, it disappears. And to close this program, it actually has a power on the screen that closes it up. It took me a long time when I first started using it to figure this out. I'm not sure how familiar everybody is with using Stellarium. This little marker here that's lit up is to set the time back to your current time, which is also very convenient. And I guess it is dark outside, so I guess that worked. But you can also slew it forward and back. I think what I'll do is I'm going to close this one in a minute and I'll open up the browser version, see some of the differences. But you do want to make sure that I think this is it, the F6 window is where you get to the location. It's the top one on the left. It's a good one to remember. I tend to use that one a lot. The other one I come down is under the configuration. Sometimes I can configure what's shown and what you can see and stuff. But I'm actually set right now for Charlotte. But if like I wanted to get to the prime meridian, right to Greenwich, um, actually I learned. Alex, how did you do this? You went to the very bottom or somewhere you went to get to the to get the time to UT time. Um, that's not coming up. There it is, Royal Observatory. So this is where if I set on this, this sets us at 0 hour. When you start looking at what times are, this allows you to set back to our time. So as we go to the left across here, each one would be another time zone. So +1, +2, and we're over here, I believe at 5, I believe is where we're at on the East Coast. And that extends all the way over to the Midwest, pretty much on our time zones. It's a pretty big area in the States for that. Okay, now I can also set this back, like I want to set back to Charlotte, which, oh, let's go to Charlotte T. Let's try Charlotte, North America. And I know this is a little bit off where I'm at. I'll use this all the time for observing if I really want to know where things are from my perspective and get that in. Okay, so I'm going to stop sharing that one. And if I open up Stellarium in the browser, and I didn't spell it right, but it's still coming up. So give me a second and I will go ahead and share this one. All right. Now this is actually, well, I didn't do it yet. Sorry, let's get the right one. This is the one. Okay. When I share this one, can you all see that okay?
Yeah.
Yes.
Yeah. Same program, but now this is the browser version. And so you notice at the bottom, all the tabs are just open. And for the time on the bottom right here, if I click on this, you get a bar like this, which allows you to move quickly between the time of day. I can also bring this back to real time, or I can go fast forward and all that. I can quickly change the day, watch the sky rotate. I can also change the month. And we can see how we get shorter and shorter nights as we get into the summer. And we are, oh, wrong one. Let me go back down. We are approaching March 20th, 21st, and that's a big part of our talk today was about um, being at the summer solstice, winter solstice, and the uh, vernal and spring equinoxes. And so one of the assignments we have today is we have to set this. And March 20th, 21st, 22nd, that's usually the time of our spring um, yeah, spring equinox, the vernal equinox, and I always think it's the 21st, 22nd. Remember those dates. The summer is in June, the fall is in now we're at 3, so we need to add 6 to be at 9, so that's September 21st, and then December 21st. Those give us our seasons that we use throughout the year. And this program will allow you to get really to figure this out. I'm gonna pull up the sun, get the sun up here. Oh, where'd you go? Oh, all right. You notice this one defaults to north all the time. I don't like that. So I'm going to swing it around. And if I get this to south, then I'll be able to find my way around here. So there's Venus over here. So let's get this going. And I'll bring the sun up over the sky. And if I click on that, I'll get the information about some of the information about the sun. And for the assignments we're getting into for this unit, I don't believe this will have enough information for what we're doing. It does have rise and set times. You might be able to use this, but I think you'll probably want to use the downloaded app because it just gives you so much more information. So if you're okay, I'm gonna bounce back and then we'll see if we have any questions. If you notice on the left, this doesn't have all the options. In fact, I always forget where it is. I can find our location. Now that didn't do it either. Boss, do you remember on the browser version where we set our location? Does that ring a bell for you?
Uh, I I think the location as it's gonna be somewhere on the bottom one. Is if you go on
Oh, there it
the
is.
yeah, yeah,
That bottom little gray thing, that's
yeah,
it.
yeah.
It's kind of hidden away.
On
It's
the lower left corner, there is a one bracket. Sometime or different. I see it on the PC, a kind of bracket. There's only, but here on the Mac might be different. Yeah,
it may be just one little doodad on the bottom left, and see here
that's a block. Yeah.
I can put my my location in here, I mean, wherever I want to be. That's what Greenwich. See if it comes up. Greenwick. Let's try this Greenwich. There we go. And this actually will allow us to do that. And I can see what's going on in England right now at the prime meridian. So I can kind of see what the sky looks like there. Or I can come back and I'm thinking it will bring me right back to, yeah, back to home just by hitting this over here. So yeah, let me go ahead and I'm going to close out of this though and go back, stop sharing that, and let me share back with the application and just show you where a few things are, how much more information you have. All right, can everybody see? Is that showing up now with the sky?
Yes.
Okay, so I need to come to the bottom and it gets larger again. And I'm going to go ahead and I can forward the time here, so I'll just get it rolling. Now we're doing this. I'm going to go add some coordinates on here. If I go to the equatorial grid, we can see where the eclipse is. This is the path that the sun's traveling across as we start talking this lesson about how the sun moves and how we determine day. And we show the whole sky is just rotating across. Each of these lines represents the width of your hand outstretched or an hour, a rotation or about 15 degrees as this comes across. I can increase the time, just be careful because it does take off sometimes. And if I want to reset it back to today's time, I hit the next dab over or set the normal time rate. But here comes the sun. So that's what I want to do. And when the sun comes up, I can pause it. All right, so a couple things about this is we do have different types of sunrise, sunsets, and we get in what's called twilight also. So twilight times, and there's two types of twilight times also. And there's reason for it. I don't have my glass with me, or I'd demonstrate that. But if I click on the sun this time, look at all that comes up. I mean, it's a crazy amount of information. We have twilights now, we have daytime, how long it thinks the day is. Um, and as I get closer to the vernal, no, yeah, spring or vernal equinox, we'd expect the daytime and nighttime to equalize out. So we can find that time and we can look at what time does the sun set and sunrise visually as we do this. That will come right off of there. Um, okay. And I can also do things like if I want to turn off the ground, that's kind of handy sometimes, or I can turn off the sky, and that's kind of handy to see where things are too sometimes. Just realize we'll see a difference because of the ground around us. And if I do back this thing up a little bit, let me go back a little bit. So when the sun looks like the sun is rising, a couple things we need to think about, and I don't have my fancy glass with me, you should have a drink with me, but I got this water bottle. And if this water bottle had any thickness to it and I fill it with some colored fluid, it would look like the fluid's at the edge because the light is refracting. And that's something we deal with on the Earth because of the atmosphere. The atmosphere will bend the light. So if it looks like the sun hasn't quite risen yet, just realize it we're seeing things a little bit late. So easier to see the sun set. When the sun sets and you think it sets, you go to the ocean and you watch in the Gulf, you watch the sun coming down on the line of the ocean, the Gulf that you can see or the water line. Just realize it's probably gone past because that light we're seeing has been bent by the atmosphere coming towards us. And it doesn't bend all the colors the same. So we're going to see the lights change. It'll start turning orange and go to red because the blue light isn't being refracted like the red. The red is refracting more. In fact, I've lost the sun. So let me come back to real time here. So as the sun's coming up and coming close, we actually end up going through the sunlight is being refracted by that atmosphere. And when we first see the light popping in, it's actually 12 minutes before sunrise is where we start to see the light glow coming. And this is the nautical twilight. And it kind of makes sense because, like, if you've been out in the ocean and you're in a boat in the middle of nowhere, there is no land mass to block that light coming around, being refracted up. Whereas now, when we get inland, we get to the civil twilight. So civil twilight is 6 minutes before the sun comes up. So this is where in the morning we see the beautiful glow. You're seeing the light, the sun start to refract through. We start to see the light illuminating it out. And I'm full of a lot of useless facts sometimes. And one thing that's kind of neat to know is if you get on top of a mountain really high up, and I have not seen this yet, it's on my bucket list, but when the sun sets, initially it's going to look nice and white, but then it'll start going towards the orange. It'll go through its colors like a rainbow. And they say if you're high enough up and looking down, you'll actually see the green flash right before it dips over the horizon from that last refraction that happens from the light going across. So, all right, that's a lot of information. How are we doing? Any questions on that?
Excuse me, this Stellarium is not is it Stellarium web or this is not web, right? This is the,
No, this one's a downloaded one. And so
yeah,
this
download. Yeah,
Solarium app,
I
and
understand. Yeah.
I don't know if I think I downloaded, I haven't, not sure if this is the most recent or not. I'm always careful to not, when I download the most recent one, I'm worried that it could cause a glitch. But I think I've had students downloading this one the last 6 months and had a lot of success. So I
Mhm.
think that it's pretty stable as it goes. It's a free program. They both are.
Yeah.
And I can drop that link into the comments here in the chat. Okay. All right, Twilight making sense, and the nautical being about 12 minutes, and then the civil being about 6 minutes, and then our sunrise, um, we're going to use that time realizing that it's going to vary a little bit because of the refraction of the Earth, but I think for our purposes, we're going to call it sunrise as we go. All right, so boss, how am I doing?
Very good. Thank you.
Okay. Do you want to go through some of the, I think I closed my WebAssign. Do you want to go through some of that?
Yeah, sure.
I'm going to quit sharing then.
Sure.
Excuse me, can this Stellarium can how can I minimize it? We cannot, right? You just get the whole page, the whole windows.
Go to the
We cannot.
very top. Try,
Very
try
top.
go to the very top. Try hit
Very
the
top.
top, see if it comes down.
Okay.
No guarantees though.
Oh.
Okay,
Uh,
let me share it my screen. Uh,
okay, I'm on. I'll put both of those in the chat.
Thank you. I think, let me see if you see it, the screen.
I see National Weather Service, twilight types.
Yeah, let me see it. Yeah.
Yeah, it was kind of actually fun. I was going through magnetism with one of my classes today, and we were talking about the North and South poles, which is related to what we're doing as we go through this. I'll try to put a couple comments at the end. A little trivia about what is the magnetic pole and where is it located
Yeah,
later on.
this is a kind of one of the pictures that I think is more by the visual, it shows very good. Normally, for example, sun, if you imagine sun comes from the east and goes to the sunset on the west. If we take it like this, we call it this one a day because it's full and there is no star visible except the moon or Venus or very bright object. But the thing is that the sun size is not zero. It is kind of about half a degree, 30 minutes it has. Therefore, although it's center of the sun located in here, we see some brightness on the daytime. And that's the reason because of the reflection, we see red color on sunrise and sunset as well. This is kind of definition that exists on the weather and also shipping and also astronomical and civil way. When the center of the sun located on here is actually sunrise and sunset. that we have. But when, for example, on the sunset, when it goes down about 6 degrees, we call it civil twilight. And that 6 degree, still we're gonna see some light on the sky, and it's not completely dark. As you see, this color here is actually very close to the color of the sky that you see it. When it goes below the 6 degrees, 12 degree, we call it nautical because that was in the old days. That is on the shipping explorer around the world. They use it. They use it specifically 12 degree. I don't know why, but we can check to the history. They call it. And then 18 degree is the astronomical because is it actually after the sun goes 18 degree below the horizon, it actually total darkness and the sky starts. And same thing on the sunrise. When it is what you call it 18 degree below the sunrise, we see some light twilight on the sky getting starting closer. The color of the sky changes like this, and suddenly the sun comes up from the horizon. Therefore, this is kind of things shows that how the twilight define it. On the project that we're going to have on the lab too, we're focusing on the civil twilight is when the sun is 6 degree below the horizon. And that's the things. If you go back to the web assigned, hopefully you see the web assigned picture that I have here. Everybody see it?
Yes.
Yeah. Then we go to lab 2. When we click lab 2, and we go to the various activity here. Also recorded recorded previous discussion that Dan provided for introduction and background and procedure. It gives us in short time on the consideration for the what activity we're going to have on this. On the lab 2, on the next few weeks, we don't want to have any observation Skynet. Therefore, the observation that we have it on lab 1 is only going to cover also in this sense, and I'm going to extend the due date a little bit more to able to upload it on the web assign as well and see how it looks like. And the objective of this lab is basically three things. One, to determine the length of a day and changes on the latitude and season. And second is determine how the height of the sun in the sky at midday changes with the latitude and season. And the last thing is that we're gonna go to the measure Earth diameter. We cannot, I think we may go today, we discussed based on the item that John provided, and I'm gonna tell, it's gonna be about item 1, a little bit item 2, we're gonna go, and the next week, we're gonna go remaining remaining of item 2 and 3. And here, as you see it on the maps, global map, normally we have this coordinate system invented by us, by human to identify the locations. 0 is the, as John mentioned, it is location that is passes meridian that passes through the Greenwich Royal Observatory on the England. And you see in the, this is a spherical uh, kind of coordinate system that we have on the Earth. And the geometry we're using for defining this one is slightly different than the flat geometry that we have on the flat surface. Therefore, here, for example, the one that is the line that you see it, we call it from the North Pole to the South Pole, we call it meridian. Meridian is a kind of a great cycle. Normally, we have two cycles on the sphere. One great cycle that is goes through the pole on representing the longitude, and also passes through the center of the Earth. It is the it calls great cycle because if you cut it, for example, if you cut it from here, this is the greatest radius of the circle, and it is radius is equal to the radius of the Earth itself. But if you cut it sideways, the circle gonna create, but it's gonna be smaller. They call it a small circle, whatever is parallel to the meridians. For each location, you have different meridians that divided the Earth is from 0 to 180 plus on the east. 0 to minus 80 on the west. Always remember, we are on the North America and South America, we are minus because we are located on the west. And when we identify the longitude, we have to put on the minus number to make sure that is correct. And the latitude also, 0 is located on the equator that is showing here. That is midway between the North Pole and South Pole. And if we go from upward toward the North Pole, it's gonna add it plus 30, 60, 90, minus 30, minus 60, and minus 90 to the south. This is kind of invention and social contract that geographer and engineer and scientists, they decided to provide what they call it, this system of the coordinate. Therefore, longitude is the constant longitude area is located on the meridians and design it like that. And also on the latitude, equator is going to be uh, bigger than the other latitudes. For example, 15 degrees, it's become smaller a little bit, 30 is smaller, 40, 60, and 70. And when we reach to the pole, the circle is actually 0. Therefore, when we go, the different cycle of the latitude has different lengths than the equator. And that's the reason that when it doesn't show on this picture, because in this picture it shows that this length is equal this length and equal all of them is same. But it's actually, this is kind of expanded projection of the map on the flat surface. And therefore, most of the area that you see it on upper latitude or lower latitude on the south, it's gonna be extended to make it a flat. Otherwise, you cannot make it a flat, like continuous flat picture here. Sometimes you see it some cut here, and therefore all the area that you see it on this line and this line is very huge compared to the actual size on the square, on the sphere. The activity that we are doing, this is the one that John briefly described it on the stellarium. We go specify the location and either from here or check from there, or based on the time zone, you can look through it accordingly. But you can put the city name here and identify the location. And the things that we're gonna do in here, for example, locate add a Chapel Hill and put whatever longitude and latitude you're gonna see. Based on this uh, picture that is showing on the Chapel Hill, how much the latitude and longitude is here given. North is 35 degree 54 minutes, and the west is 79 degree and 3 minutes. And therefore, for here, we just put 36 because it's closer. 54 is closer to the 60. We're gonna put 36 here and minus 79 here. This is kind of activities that you gonna proceed. And then the next thing is we're going to identify the season. This is one of the key misunderstanding, although it is on the 21st century. And if you ask 1,000 people around the country, you may get different question and answers. And but this is the things that normally all the pictures on the NASA and every science articles, things like that, they're showing like this. It's a circle, sun is in the middle, and the winter, summer, and vernal equinox, spring, and the fall is going to be on the other side. But it seems to be all of them, it's the same distance, and therefore we don't recognize why on the winter here we are colder on the northern hemisphere, and in the summer we are hotter. The reason is that because of the this inclination of the axis of the rotation of the Earth. The rotation of the Earth compared to the celestial pole is going to be 23.5 degree. Therefore, that's the reason that is causing the uh, what to call it season. If we look through the diagram again on sideway, this orientation of the axis gonna keep along the orbit around the sun or revolution. Therefore, whenever we are in here or here, it's gonna be different. The reason is that here on the north hemisphere, it's gonna be directly above ourselves. You see it on the, you notice it if you make attention on the data. Uh, you see on the winter right now, if you go out when it is sun up, don't look through the sun, but you look through the elevation compared to the horizon. You see it comes lower compared to this summertime. Summertime, sun is located hot up, and the direction of the sunlight is more direct than the winter. This picture shows very good on the down here. For example, on here, on the summer, the sun waves rays gonna be distributed on less area. Therefore, intention of the sun rays gonna be much more than the one distributed for the longer area here. You see, this circle is smaller than this circle. It shows that here on the summertime or when it is higher on the sky, it's gonna get more energy on the square inch or a square centimeter or a square meter of the Earth. Therefore, the main reason that we have a summer hot is it because of this angle of the uh, uh, sun compared to the uh, horizon, or actually, and the main reason is that because of this uh, angle that rotation of the axis of rotation of the sun make it with the celestial pole. And it doesn't mean that when it is sun is closer to us, or in winter is the sun is farther away from us. This is actually reverse. It is on the sun probably around I don't remember top of my head how many kilometer away, but it is about 100 10% or so. You have to look through the NASA data to see it. But on the summer, the sun is farther down from us, but on the winter it is closer. And that is reverse. That most of the people think that, or myself, when I didn't know that, I thought when it is closer, it is become hot because it's closer to us. But the distance between the sun and Earth is not related to the temperature and season on the Earth. But whatever it is important is the direction of the angle of the uh, kind of solar ray in here. For example, this question say, if it is a summer solstice is the north hemisphere, what is the uh, southern hemisphere? When we have, for example, in here, the sun angle on the northern hemisphere is gonna be on right on more angle on here compared to the horizon. What's we're gonna have? We're gonna have a summer solstice also on the southern hemisphere.
No, I think it's reverse. Yeah.
Yeah, yeah, it is
Yeah.
reversed. Therefore, when we have summer solstice on northern hemisphere, we're gonna have winter solstice
Winter.
on the kind of southern. Same
Yeah.
thing here. When we have a winter solstice on the northern hemisphere, we're gonna have summer solstice here. Same thing on the vernal equinox. When we have vernal equinox on the northern hemisphere, we're gonna have fall equinox on the southern hemisphere and reverse. Therefore, all these seasons gonna be reverse. Either we look through the northern or southern hemisphere. And next activity that we're gonna have is the kind of we locate, as John mentioned, we identify the city and kind of daytime and based on the stellarium, how the side of the length exists. And I'm gonna go over a little bit more on that, but remember that all the values that you're gonna provide here, you provide minimum 3 significant digit. 6.0333, and this is 4, a little bit more. And always you put based on the hours. How they're gonna convert the hours if it is not given? For example, in here, sometimes it gives the data, for example, let me show here 13 one of the rise, for example, 6 hours 15 minutes. You're converting this one 6 plus 15 divided by 60. That's gonna be easy to calculate and put the as a decimal point based on the hours here. Any questions so far?
I'm going to interject just a couple things real quick. Yeah, these are big points. This is good. This last thing, especially. And one thing I want to make sure we're clear about, because this comes up a lot. Like a lot of people think that the Earth's wobbling around and that causes our seasons as we get closer and farther. But just to clarify, our Earth is like a giant bowling ball with incredible amount of mass, so much so that when it spins, it doesn't want to rotate. And that rotation is actually extremely slow. And it does rotate, but that cycle's 12,000 years. So that's why we have our seasons, because the Earth doesn't wobble. I mean, it'll wobble, but it's precession. They're like a top. If you've ever spun a top on a surface, you'll see it kind of precess around, and that's normal. But that precession is extremely slow. And one thing you said, which makes me wonder if we are actually farther away in the winter and closer in the winter and farther in the summer. I wonder if the south hemisphere doesn't have a little warmer summers than we do, which is kind of interesting. Um, so I hope that makes sense, is that it is a slow wobble. Now that wobble does mean that after you stick around for 6,000 years, you're going to find that the North Pole Polaris will no longer be the North Pole. It actually switches over to Vega, I believe, at that point, and it'll come back around to maybe to Polaris or another star as it keeps going. So the North Pole actually has changed historically over the last few thousand years. Polaris right now is pretty close to being right on it, but that precession does make a difference. So I hope that makes sense. The second thing which we're getting into is really to make sure that when you have like an angle like 30 degrees and 15 minutes, that's not 30.15. You have to make sure you're converting these minutes into decimals. So 30, there's 60 minutes, divide that 15 by 60. So it's actually 15 minutes is 0.25. And that's what Abbas was leaving off on. I'm gonna let you go back at it with that because that was a good point.
I thank you for pointing. Is actually we know that on the Earth. Do you see the picture that I showed the precision of the Earth axis? Yeah. This is kind of probably many of us when I was kid, we just playing with this kind of what we call it, a spinner that very famous that we do it spin around it. But actually, when the sun is rotating, right now its angle is 23 and a half here. It's gonna stay here for after about 13,000 years. It's gonna be slightly other direction. Therefore, this total rotations, it's gonna take around 26,000 years. Based on the archaeological studies and astronomical data that we have and from ancient Egypt, the location of the what to call it, this axis extension right now is close to the Polaris, the North Pole star. But at that time was another star they call it Thoban, that in the another constellation on the northern hemisphere. And as John mentioned, after 13,000 years, we're gonna go to the Vega, another star. Therefore, this orientation of the North Pole gonna change slightly. And also, on the other hand, this is not only the kind of work of the system that we had. Earth may have around 7 or 8 different kind of orientation and axes that some of them is very difficult to maneuver. But normally this gonna be takes a lot of time during the year and kind of day and night. It's not be observable. The basic things that we have here is to consider one of the calculation that I mentioned. We have some sample calculation. For example, 18 hours and 15 minutes. For the decimal hours, we have to use this formula, and then we put it this one on the what to call it, the information that requested on the lab. But we can check the error also based on the measured value versus the professional best value that we had. And if it is 98.785 minus 10 divided by 10, we're going to get about 1.5% kind of percentage error that you can calculate based on the that sample example that is provided here. And the other thing that we needed to do, we go to look through the length of the day and night on the March 21st, June 21st, September 21st, and December 21st as representative of the this winter, vernal, and summer or autumn equinoxes. Therefore, for that purpose, I'm going to show you later on. But this one, we're going to look through the 5 different locations on the Earth. One, a location very close to the North Pole, for example, near to the Arctic Circle. You can choose any city that it is close to that region. We don't need it to be exactly, but it is needed to be mentioned like this, where Arctic Circle is 66.6 degree plus. And if it is something on the northern hemisphere, we can choose Chapel Hill or something else. And one city near the equator. And also one on the tropical Capricorn on the southern hemisphere, and one on minus 66 on the Antarctic Circle as well. Then when we're choosing this 5 item, for example, in here on the Antarctic region, we can use Bisco Island. Then we just identify those and calculate the latitude and longitude, and then provide in here. This is kind of very trivial and easy to do. You identify the name of the city for 5 location. 5 location, you're gonna choose any places around this region, around the Earth, and then identify the what do you call it? Uh, it is northern hemisphere or southern hemisphere, and give the what do you call it? The angle here. Whatever is minus is the southern, and whatever is plus is the northern hemisphere. You see here, the individual that chooses this example, it doesn't look through the 0 degree, and it is right around that. It's not important to have 0, minus 66 or 66 or 30. It is kind of shows to how those latitudes is changed. And also we're gonna look through the sunrise and sunset time, and on the winter solstice, summer solstice, autumn equinox, and vernal equinox for the same cities. And therefore, this is kind of a very trivial activity and easy, but you have to make sure you go one by one. When you repeat these things more and more, you learn better. And after this course and session, you're going to be easily maneuver Stellarium and get other data that is needed. This is a very good activity. And as I mentioned, Skynet and WebAssign and also OPIS 2025 that we have this class is it is not like you just read one time and you completely understand. But this is the things that you need to practice and get a more interactive way to get the material on the subject of the activities. And I think this is the main brief description of the what activity we have. I just pause a little bit to see if I have any question about these topics I presented. Then I go and show very quickly one of the activities, for example, finding the city on a solarium and how we get the data for the longitude and latitude, and also the sunrise and sun time and the length of the day. Any question? Hearing none. Let me go stop
Doing great.
sharing.
Go on. I try to look through our list we've talked about before and where we're going with things. I think you're doing pretty good. A couple things, just in case I'll throw a little more trivia here, is as we're working through day length of day, we're talking about North Poles and South Poles and equinox and all that. So our geographic North Pole is up at the north, geographic South Pole is at the south. One neat thing kind of to know, usually everybody talks about the North Magnetic Pole and geographic pole like they're synonymous, like they're the same place. But there is actually quite a bit of separation distance between the poles. It's I think I had about I think it's like 1,000 miles actually. It's if it's that much, it's quite a ways apart, between the two. And also a neat thing to realize is even though we call the North Geographic and North Magnetic Pole next to each other both north, that's actually not accurate. That if you take a compass has a north and south pole, and the north poles will point to south, and south poles point to opposites attract with magnets. So technically, at the north geographic pole, the one on the north side of our hemisphere, the upper part of the hemisphere, is actually the south magnetic pole. And then the one on the south hemisphere is actually the north magnetic pole. So I think you see this online sometimes, they just do it incorrectly on maps and stuff. But if you do some research on it with astronomy, we realize that the North Geographic, and that's the one we're using, is North Geographic for everything. Everything is spinning around the North Geographic. Magnetic pole is very contingent what's happening inside the Earth, and our molten core moving around is generating the magnetic field, which is protecting us. But it actually does flux at the north, at the south end, and south is at the north. So just a little thing to kind of throw in to kind of interrupt you there. Bosch doing great. Yeah, we'll keep going. Any other
Thank you.
question?
Any question? Yeah, I'm gonna go again to the stellarium. Hopefully, I show you what is meant here. Do you see a stellarium in the screen?
Yes.
Okay, yeah. Here, for example, we locate we can choose the city from here just randomly if you need it, but when you select in here, it shows here also as well on the left side with the arrow. For example, here you change it, the locations, it identify the various location. For example, this is a city in Southern America, and then the name is here, and is actually, this is a kind of latitude and longitude. This shows directly here. There's how much it is southern, 27 degree 3 minute, and the western is 65 24. Therefore, you just this 16 24 because it's west also gonna be minus, and also because it's south gonna be minus also. Therefore, on that data that you're gonna I showed you before, you have to put it accordingly. These values on here. Any question about this getting the latitude and longitude from the this stellarium? Okay, then we go to the in here we identify, for example, if we are in here, we just identify the location, and we go look through the sun. Okay, sun is located here. I close this one. Okay, and enlarge it to see better. And here, as you see it, the sun, they give many information here. The two important information here, it shows the morning twilight -6 degree and evening twilight minus plus -6 degree also. And this gives us the time, what evening time gonna be, this twilight gonna happen. And the sunrise and the other information that he had here, it gives us some, this is a sunrise about 7 hours 15 minutes, and sunset is the 19 hours 54 minutes for that location. Therefore, these are the information that you can get it directly, and also there is some information exists. You see the numbers are changing because it is, we don't stop the time, it's always changing. There is some location, you can find it here, the what to call it, length of the day. I believe it should be somewhere here. Or it might be somewhere else, we have to find it. Oh, the one that yeah, the one that we have it here, we have to put these numbers. For example, on the I'm gonna show the table again. Sunrise is 7:15, and sunset is 19:54. You calculate one time by this one, and then one time between the twilight and the evening to see how much they are different from each other. Therefore, the sunrise and sunset here is different. You see the sunrise 7:15 and morning twilight, how much it is? 6:49. Therefore, 6:49 is lower than that. It shows it doesn't comes up to the horizon yet. Therefore, this is kind of a definition that you can use it. For the sunset and sunrise, you're going to use these numbers to get the actual kind of daytime on the practice that we're going to have. This is kind of basic information that we're going to have. Let me stop again and go to the main activity that we have. Here, you're going to see it on this. You put the sunrise for that city. For example, 7:15, you have to 7 plus 15 divided by 60, and also the other one for sunset, and then you calculate the length of the day based on the hours. And you do the same thing. Oh, yeah, sorry, I forgot this one. We have this one for the different solstice and equinoxes. Therefore, we have to go here. Do you see the screen right now for the Stellarium?
No.
No? Let me share it again. Okay. In here, you go back on this area, and then you go the timing. On the timing, you go to the, for example, summer, March 21st. I'm gonna go March 21st here, and you go back to the location, summer 25. It's gonna be, gives you, okay, time zone is defined, and the north, no, this is the location that we needed here, yeah. You have to click again when you're back to make sure that the numbers are correctly assigned for here. Therefore, in this location, you just identify the time by the second arrow here. This is daytime. And we go to the one time March 31st, one time June 31st, one time September 31st, and one time December 31st. Therefore, based on those information, you will search for the sun. Here is the December 21st. Then here the data is changing. For example, rise is 6:27 and sunset is 20:13. Therefore, you just record these two and subtract those and get the length of the day on the table. Therefore, on the table, you're going to have on here, you get this data, for example, for winter solstice, and then for the northern hemisphere, and same thing for the summer solstice on the southern hemisphere, if you need it for the each item as well, based on the discussion that we have. Therefore, you have a choice here. Northern hemisphere gonna be southern hemisphere reverse. You see, this summer is winter, northern, southern. All of them is assigned in a way. Either you choose the either cities, you can have data accordingly provided here and submit your application, and then you provide the kind of notes based on this experience, how you learn and what you get the information from the object. Yes, Ripa, you had a question?
Yeah, I was just wondering how to purchase the access code for the WebAssign.
Yeah, I told you that oh, you want to show you that screen?
Yeah.
Okay, yes, just hold on a second. I stop this one. For this subject, do you have any question? Everybody? Everybody's okay?
Yeah, okay.
Okay.
Yeah.
Yeah, if you can share it your screen, I will show you on the screen if it is we have about few minutes left. If you wanna able to share your screen, I will show you.
Let me just pull that up over here.
Let me see if I ask everybody can share it.
I think we're in a good place too. We've covered most of the bullet points I had for today's lesson. And I'll see if there's any loose ends. I think that we're in pretty good shape. If you do get into this lesson and start to use the Astromancer, which is the plotting program, there are
Yeah.
two versions, and I think you'll want to use the old one, not the newer one for what we're doing. But I could be wrong on that. Just watch the
Yeah,
video.
yeah, I
Yeah.
didn't go to that one because I wanna because that is kind of a little bit further down on the earth Ignatio, I'm gonna go later on this item later for this case.
Yeah, good content today, I think. Hopefully everybody's doing well, I hope, with the content and all that.
I can share my screen. And,
Yes, Kripa, can you able to share it?
can you see my screen?
It is seen black. Yeah, I see that. Yeah.
Mhm.
So when it says purchase WebAssign, it says that I need to enter an access code, and
No,
it says
no, no. Go to the start. Close this one. Start from the beginning.
okay. So if I press, if I can't access the
No,
course.
no, no. You have to. I think you go back to the main. You go to back to profile on the left. Did you log in with your original login?
Yes.
Okay, click login again.
So should I sign out?
Yeah, just do it again from the beginning.
Um, so
Oh, yeah, probably you didn't added the course yet on your profile. Just click that plus sign.
I have the course here. That's using the class key that you provided.
Oh, you have it over there. Okay, just yes, purchase the, yeah, you have to click that one. Enter
And then
access.
it says that I have to enter an access code, and then when I ask how can I find my access code, it says that I need to purchase it with the Cengage textbook. And I'm not really sure how to find the textbook.
Okay, I get you. Okay, I will send it to you. I didn't know that this is probably they closed that one. I will send it to you, that access code. Make sure that I have it. Let me see if I have it after the meeting. I'm gonna send it to you.
All right,
Sure, thank you. Thank you for showing, because normally I think because it's past more than 2 weeks, those are closed. But I see it, your name is there. But just close that one, close that window, and open the, yeah, close that one. Click on the under the over that course name, Astro 100L. You can have any click over there? No? Okay, then yeah, normally it should ask. I will ask them to see, but normally it's better when you purchase the WebAssign, it's gonna gives you. But I will check with the WebAssign and get back to you what if they needed access code, then I will send it to you by email for everybody.
All right.
Thank you. Thank you for showing me that one, because it is kind of sometimes it's very difficult to figure it out what's happening for the others, although you have access, but you don't know the others get in trouble on that. Thank you for letting me know, Kripa.
No problem.
Okay. Any question for this
Thank you.
Tonight? And I hope you have. This is kind of very simple things. Just you have to go to the solarium and play with it, and get the sunrise and sunset, and get the length of the day for 5 city, 4 different time of the year. So 321, 621, 921, and 1221. And those maybe changes from the year to year, but we needed to practice to make sure that we have all the things are on place. And we go to the next week. We're gonna study about how to calculate the Earth diameter, and also how they investigate as on the another program we have, Astromancer, to get the graphs of the data that we get for sunrise and length of the day, sunset. Any question, John? Anyone? Any things you want to add?
That was very well done. I think we've covered the bases. And just glad everybody joined us tonight. And hopefully that was good for everybody, learned something, and I'm looking forward to the next meeting. So
Okay.
any questions from
Thank
anybody? Are we doing okay?
Excuse me, the Saturday session is the extent of this session or just separate? Because I didn't participate last two session or something. Is it like mandatory? Something extension of this one or not?
Our first lesson, we basically did that first lesson over multiple weeks. That's what we kind of did. And now we're moving into the second lesson. So we're just trying to touch base on details that go through. And Abbas has done a nice job. If he's recorded off the videos of
Yeah,
last lesson. But we
sure.
do the same thing basically 3 times that we've been doing: Tuesday, Saturday, and Sunday to go through. So
Okay.
if you hit any of those three,
Yeah, exactly. As John mentioned, for a week that they have, for example, if we started the week with the session lab 2, week 2 on the Sunday, we're gonna repeat it on the Tuesday. We're gonna repeat it almost the same on the Saturday, and we try to make sure that 3 times we repeat those and make sure that those are aligned to each other. Therefore,
keep a little
they are not.
checklist too.
There might be a slight difference between them, but almost the same.
So, Abbas, then I only attend the Tuesday sessions. So what I heard, I'm not missing anything because every Tuesday there is a separate session
That's
that
right.
is repeated on Saturday and Sunday.
Exactly. That's right. Therefore, we just try to, I cannot say 100%, but just we try to 95% cover almost everything they needed. And also, those are as recorded. You can go over and glance over, see it. If you find something, we describe it more on the specific. Sometime you see it happen. On this Saturday, we have more question. We go deeper on that. For example, on Tuesday, there is no question. We don't go much deeper. Therefore, that specific topic. But you may find that might be beneficial if you glance over to see if you find anything that you get benefit.
And also, as a student, I heard the good news that you postponed the submission of the homework. Was that right?
Yeah, I'm going to postpone. Right now, the March 3 is the deadline for the lab 1. But based on my own experience, this is very short. I think there is more activity on lab 1 we have, and I try to extend it another 2 weeks. Probably it's gonna happen, and therefore I'm gonna move it toward the end of the March lab 1.
Okay, yeah, but on
Thank
my program, it shows still March 3rd. That's why I had targeted for, but now that you said, I may slip a little bit.
Yeah, that's right.
Yeah.
Well, as we're doing this, it's always good to work ahead, always. But also, I think a lot of this stuff, like this lesson 1 stuff, I'm going to do this the next year. I'm doing it now, but I'm going to do this through the summer and fall too. I'm ready to use some of those credits and see what I can see.
Yeah, sure. Yeah, but we are. You are a teacher, John, and the student. They like this rescheduling the submission of
They
the
do.
homework.
Procrastination. It's a tough one. Yes.
Okay, thank you. No, that's good.
Okay. Thank you, everyone, for joining.
Thank
If
you.
you don't have a question, we just say happy evening, everybody, and enjoy the another activities and observation of the uh, uh, sky and photo. And also remember that make a schedule for 13, 14 of the March. That is a lunar eclipse on the North America. Hopefully clear sky at that time and observe it on that as well. And we get good pictures from you guys by cell phone or because the moon is very easier and longer than the solar eclipse. The solar eclipse a few minutes, but lunar eclipse a few hours. Therefore, that's hopefully more clearer sky and everybody enjoy the times around. And this, if you had any question, just do not hesitate to ask us. Send the email or group me, then we can get back to you as soon as we can.
And I'd encourage you, as that moment comes up, that eclipse night, I know I'm going to try to schedule some observations during the eclipse just to see how they come out. It might be a fun opportunity to see what we can come up with.
That's good. That's good. Okay. Have a good
Thank you.
evening, everyone. and see you next time.
Yeah.
Keep looking.
Thank you so much. Thank
You're
you.
welcome.
Have a